So what do these objects have in common? That's right, they all use convection. Today's tutorial is all about convection. The learning objectives for today are: what is convection? Why does convection occur? And where can convection take place? Today's keywords are convection, bulk movement, fluid, and convection current. So what is convection? Well, my favourite definition for convection is this one. Convection is a transfer of energy due to the bulk movement of particles within a heated fluid. So, which of the following are fluids? That's right, liquid and gas. Liquids and gases are fluids because they can be made to flow, as their particles can move from place to place. So why does convection occur? Well, energy is transferred by heating to the thermal energy store of the liquid or gas. Then this energy is then shared across the kinetic energy stores of the particles. So when you heat a region of a fluid, the particles will move faster and the space between the particles will increase. This causes the density of this region being heated to decrease. So if we look at this animation here, you can see the particles within this area, okay? If these particles are heated, then they move further apart. And because of this, within a given volume, the number of particles will decrease, which means that you have a smaller mass within a given volume. This means that your density will decrease. So, because fluids can flow, the warmer and less dense region will rise above the denser, cooler regions. And this means it moves away, taking its energy with it. Then the denser cold liquid or gas will fall into the warm area and the cycle will repeat. So if there is a constant transfer of energy by heating to a substance, a convection current can be created, and the convection current will transfer heat from place to place. So you can see here that the ground will heat up the air during the day. That hot air will warm and rise. And you can see that as it rises, it will cool, become more dense and sink. And a convection current is established. So just to make sure you understand convection, what I would like you to do is put these sentences into the correct order. Pause your video whilst you're doing this, and then resume the play when you're ready to check your answers. Okay, so these should have been your correct answers. When you heat a region of a gas or liquid, the particles will move faster, and the space between the individual particles increases. This causes the density of the region being heated to decrease. And because liquids and gases can flow, the warmer and less dense region will rise above the denser, cooler region. The denser cold liquid or gas will fall into the warm areas, and in this way, convection currents that transfer heat from place to place are set up. So your answer should have been E, C, D, B, A. So well done, those who got that right. So examples of convection. So how does a lava lamp work? Well, you can see in this lava lamp here, you've got wax and then you've got a coloured liquid. Well, convection currents can be seen in lava lamps. The wax inside the lamp warms up, and that's because you've got a bulb in here, and that heats up the wax. The wax becomes less dense than the liquid, and so the wax will rise. When the wax rises, it cools and becomes denser again, causing it to sink. So, how would you explain how a radiator heats a room? So what I would like you to do, I'd like you to pause the video and use that diagram to explain how a radiator heats a room using convection. Once you've finished, then press play to go through the answers. Okay, for some of you, you might have needed a little bit more support with this answer. If you feel you need a little bit more support, then try and guess which words could substitute the boxes A to H. Pause the video while you try to guess what those words might be. Right, okay. Air particles collide with the radiator surface. So initially, energy is transferred from the radiator to the air particles by conduction. The air by the radiator becomes warmer and the particles move faster. The space between individual particles increases and the air becomes less dense. The warm air rises above the cooler, denser air, taking its energy with it. The warm air is then replaced by cooler air. The cooler air is then heated by the radiator, and at the same time, the previously heated air transfers its energy to the surroundings, for example, the walls and the contents of the room. This air then cools, becomes denser and sinks, and the cycle repeats, causing a flow of air to circulate round the room. This is a convection current. So hopefully you can all explain now how a radiator can heat a room. So why is a freezer compartment usually at the top of a fridge? Pause the video now and try and explain using ideas about convection. So the freezer compartment is usually at the top of the fridge because cool air is dense, so sinks. The freezer cools the air at the top, and then this cold air cools the food on the way down as it's sinking. It's warmer at the bottom of the fridge. The warmer air from the bottom of the fridge will rise, and a convection current is set up inside the fridge, which helps to keep the fridge cool. So, how does an electric kettle work? Pause your video and try and use the diagram on the right-hand side to explain how this kettle works. Right, well, the heating element is placed at the bottom of a kettle. That's not clear necessarily from this diagram actually, but it would be at the very bottom of the kettle. Energy is transferred to the thermal energy store of the water at the bottom of the kettle, initially by conduction. So it works in a very similar way to the radiator. So water particles would actually collide with that heating element, and that you can see heat is transferred by conduction initially. These water molecules will then move faster, and the spaces between individual molecules increase. This makes the water at the bottom of the kettle less dense. The hotter, less dense water will then rise up through the cooler water. The cooler water at the top, which is denser, will sink to the bottom. And so convection current is set up inside the fridge, which helps to keep the fridge cool. A convection current is set up inside the kettle to heat the water. So there are other examples. Convection explains why hot air balloons rise, and also why it's often hotter in the lofts of houses than downstairs. As well as these examples, convection can be seen on a much bigger scale in our weather and ocean currents. So convection currents cause daily patterns of clouds, wind, rain, and air pressure. So you can see here in this diagram that during the day, the warm land will heat the air up. The hot air will rise because it's less dense. And then what will happen is the cooler air will be drawn in from above the sea where it's cooler. And of course, this circulating air is a convection current. You can see the reverse happens at night. Because water has a very high specific heat capacity, at night, the sea is usually warmer and the land is cooler. And you can see the direction of the convection current reverses. So this is why we feel breezes. This is why we have wind. This is why we have even really extreme weather like hurricanes. So just to check your understanding, what I'd like you to do is attempt this true, false quiz. So write down 1 to 6, and if you think the statement is true, write true down. If you think it's false, write false. Pause your video whilst you attempt this activity. Okay, So convection is the transfer of energy due to the bulk movement of particles within a heated fluid. That is true. Number 2, the freezer compartment is at the bottom of a fridge because cool air is dense as sinks. No, that's false. And the reason why that's false is because a freezer compartment is found at the top of a fridge. And yes, cool air is dense, so it will then sink. Number 3. This one's true. Initially, energy is transferred from a radiator to the air particles by conduction. Question 4. When you heat a region of a gas or liquid, the particles do move faster, but the space between the individual particles doesn't decrease, it increases. And that's why that heated region of a gas or liquid becomes less dense. Right, number 5. Convection explains it is often cooler in the lofts of houses rather than downstairs. Well, that's false because it's often warmer, not cooler, in the lofts of houses rather than downstairs, because we know that hot air rises. And finally, number 6, the liquid inside a lava lamp is not the substance that becomes less dense. It's wax. It's actually the wax inside a lava lamp that warms up and becomes less dense. And it's less dense than the liquid. And this is why the wax rises. So to correct this final statement, you would literally have to reverse liquid and wax in this statement. So for those who got most of those right, then well done. If you need to re-watch the tutorial to make sure you understand any of those 6, then please do. Thank you for listening.